So we're still assuming the same things we've been for this example up until now. We've got $5,000. It's growing at a rate of 6% per year, and it's earning interest on a continuous basis here. So now we want to link back, take these ideas of growth, and go back to the original idea here in this topic, which is average rate of change. So let's suppose we take this investment and we compare year 5 to year 20. At year 5, there's some particular value that the investment holds. Year 20, same thing. But now we can ask the question, what is the average rate of growth between year 5 and year 20? Or how fast is the investment growing in this time period? So if we assume a continuous compounding situation, we can think of the future value formula as a function, capital F, that depends on time t that the investment has been allowed to grow. So we have on the right side the $5,000 is our principal P, e raised to the 0.06 times t, where 0.06 of course is the rate per year and t is time. So we can draw this picture, we've seen a picture of this, and in this situation, in this particular example, we need to locate where the 2 points at year 5 and year 20 are located. So the function evaluated at 5 can be found either by using a calculator or by a spreadsheet or maybe even using the graphing software, but the future value at time 5 is about $6,749.29, and the future value at 20 years is about $16,600.60. So what we want to do here is keep in mind that this basically represents 2 points. The first point is on the horizontal axis. The value there is 5. The vertical axis is 6749. So that's like an XY point, 5, 6749. The second point is 20, 16,600. So you really have 2 points. Anytime you have 2 points, you can find the slope of the line that goes between them, and that's what this last calculation does. It calculates the average rate of change, or the slope, between those 2 points by doing a quick slope calculation. And this number ends up being about 656.75. So let's see what that means. Because this is a rate of change calculation, we need to be careful with the units. So we would say the following: between years 5 and 20 of this investment, that investment is growing at an average rate of $656.75 per year. So again, notice the dollars per year. The units are something per something. In this case, the vertical axis represents dollars of investment. The horizontal axis represents time in years, so the units are dollars per year. So on average, this investment is growing at that particular rate. That does not say that if you were to look at the value from year 5 to year 6, and then from year 6 to year 7, and so on, that it would always be that number. No, in fact, each one of those time periods is going to have a different increase. But if you look at the average, this is the number that you get. Here's a visual representation of what's going on. Once again, here you have the future value graph in front of you. And so what we're doing here is we're saying at year 5, there's the point on the graph, and year 20, there's the point on the graph. You've got 2 points on that graph. You can see that the future value has increased. And what we're doing when we calculate the average rate of change, as we said earlier in the topic, is we're creating a line that goes between those 2 points and then measuring that slope very accurately. The slope of that line is 656.75.